Cool. Mr. Achille, do you want to introduce yourself? And then I can stop sharing my screen for you, and then you can kind of take over.
Yeah, absolutely. First of all, thanks for having me. Exciting to speak for you guys. From the video, that's the first time I actually heard of you, but it's cool to see what you guys are up to. I didn't really get a lot of background on what you guys want to hear from me, so I hope this is somewhat interactive, and you can stop me at any point to ask questions or say this is boring. Let's skip to the next thing. So with that, I'm just gonna share my screen. Let me know if you can see anything.
Yeah, you're good.
Awesome. All right, cool. So this is just kind of an overview slide that I use for presentations about some things that I do. So I'm going to move right ahead. I'm going to kind of split this up into kind of my curriculum, what I did in my life, and I promise it gets more interesting later on in life. So from 0 to 18, I actually didn't do that much. I was born and raised in Belgium. I am Belgian by nationality. I lived in Atlanta for 2 years as a little kid. In high school, I studied Latin and mathematics, Latin for 6 years. If I were to be able to choose again, I would do science mathematics. Latin didn't really bring me that much other than just the language. I spent one summer in New York at Columbia University, and then I interned in Tel Aviv for one summer at a medical device startup, because for part of my career, I thought I was going to do medical robotics or medical devices. That was really cool. So after that, I studied at the University of Leuven, which is also in Belgium. You can see it like over here on the map. If you're not really familiar with Belgium or Western Europe. The interesting thing about growing up or doing your college in Belgium is that you show up at on the first day of school or first day of college with your high school diploma, and you basically just walk in, and you don't need to show grades or whatever. You just need to have graduated, which is very interesting and actually played a big role in kind of like my career development in my life and how I see things. What that also means is that the college degree itself is pretty hard, whereas as I understand it, in the US, once you kind of get selected for some kind of competitive program, you probably already have the chops to go get in and be successful and get good grades. The weeding out of the students happens in college itself. So a lot of students kind of tend to fall off in the first year because finals are really hard. We don't have any tests during the year. You'd have 2 semesters. At the end of the semester, you get a finals period, and that's the only grade that you get. And if you pass, you pass, and if you fail, you fail. And then you get a second chance in the summer to make up for any exams that you failed for. And because of that, less than 50% of the people who start, about 600 my year, actually graduated. And the ones who fell off went to do something else. And then halfway through, you start just doing engineering sciences, so that you don't start specifically mechanical engineering, computer science. You just do engineering. You learn a little bit of everything. And then after a year and a half, I specialized in mechanical engineering, computer science. So I got to do both, which ended up being a good choice for going down the robotics route. I was one of those people who failed everything. My first semester out of the 5 classes that I took, that everyone took, there's no choice. I failed every single one of them. And failing means getting like less than a 10 out of 20. Again, exams are pretty hard. I didn't really know how to study correctly. I didn't really understand the material that I was going through. I was kind of taught to memorize and kind of reproduce. And it turns out that engineering is really a very different way of studying, a very different way of thinking, where it revolves all around understanding and not just kind of reproducing the material like I was taught in high school. And so they told me after that first semester, you only have a 5% chance of making it in 3 years. Bachelors in a lot of European countries are only 3 years, not 4. I was lucky enough to be one of them, and that was a lot of hard work and I guess being crazy enough to defy the odds. And I think that's actually really important. During my third year, I was the president of a 499-year-old student association in Durham, founded by one of the popes themselves, or himself, which was really cool, and actually made a lot of friends and connections that way. Some people going into robotics, but also some people going into various degrees. And we had our own bar where we hosted like nights and parties and whatnot, which is awesome. I then took off, and this is kind of took off to the US, and this is kind of unusual because in Belgium, if you graduate without a master's, you're not called an engineer. You don't get the title. And there's an official title in Belgium for engineers. I actually had to like go through a specific process to get my bachelor's diploma, because it's so unusual to not just get your bachelor's and your master's in one go. And the reason for that is that I had the opportunity to go and be a junior researcher at a lab in Boston. And the way I got that was just by reaching out saying, hey, do you guys need anyone? And I think I got lucky there. And it was there where I did biomedical research at the Edelman lab, where I started attending robotics lectures. I always had some kind of interest in robotics, but it was mostly kind of biomedical that I wanted to do. I figured it out. And this was a really good way to say like, hey, actually, robotics is really where I want to be. Although medical is cool, it's that was not, for me personally, that was not the place I wanted to be. Also, my roommate at the time was an aerospace PhD at MIT, and we talked about robots, and later on actually ended up starting a company with the robot here on the left. And that's also around the time that I started realizing, hey, this is not that bad. I might want to stay here. So after half a year of being in the US, I decided, maybe I should consider applying for some universities here. Applied for a whole bunch of them, got rejected from most of them because my grades were like above average and actually pretty good in Belgium. But when you translate that to the 4.0 system, GPA system in the US, I suddenly was like kind of dumb. And so luckily I got into, there was one German university I could of course attend, the university I was already at, and then I got into UPenn, which happens to have a really great program in robotics. And those of you who are interested in applying or making selections of what school they want to go to, I'd be more than happy to talk about that, and why you should choose Penn and or other universities. Then I started at Penn, was there for 2 years for my Master's of Science in Engineering. That's when I did a lot of robots, and also learned a lot of nuances about what robotics is and what it's not. I had a mostly mechanical engineering background, but also some computer science. And as you probably have realized with FTC, a lot of robotics is actually software, and there is a significant part mechanical engineering, and there is electronics engineering, but a lot of the more interesting stuff, where most of it happens to be in software. And so that's kind of where I had to refine my software engineering chops, and actually learned a lot about that. I also started that company with another student in my program, and with my former roommate then. We decided to build something, prototype. We did some machining, built this little robot that is basically 2 arms attached to each other and can climb on scaffolding structures. And the idea was to climb on scaffolding-based structures, like at construction sites or at cell towers, and do kind of like maintenance work. And you show up as an engineer to any of these pitch competitions. You have a real robot that you can show to them, and all of these business people are like, oh my god, that's so cool, and they want to give you money. And that's what ended up happening. And we use that in retrospect, little money to spend some time building that robot. And I think this might be the first time that I show a real video. Oh, this one it is. So at Penn, this is one of the things that we built. One of the classes is an advanced graduate level course where you actually build a service robot that moves around in any environment, indoor environment, and can like do exploration and whatnot. And this was built in ROS, and this was really a cool way to get acquainted with service robots. Service robots being these like mobile robots that mostly work in human environments and do stuff for you. So this robot could go and make you a cup of coffee with the little arm that was on it. It could open doors. It can go to elevators. It could give people tours. And here I was showing some kind of exploration function where it would go somewhere and try to check out the environment and build an understanding of the world around it. And so it kind of had like this early, deep learning pipeline on it, where it like would recognize things like chairs and doors, and then would report on what it had seen and store that in some kind of database. So that was a really cool way to get into that. I'd never learned things like ROS, C++ programming, Python programming, a lot of like integration with robotics, and this was a really cool way to do so. And it turns out that because I love that, as I love that so much, that the next job that I took actually happened to be in the same field. But first, a quick video, and this is never shown before, seen me before. That was one of my robotics colleagues. This was a little climbing robot, and this is all homemade except for the motors, or everything is built to spec. And that was like the first real like homemade robot that we did, and just kind of a good way to figure out this is startup thing, something that we want to do. So yeah, here it's climbing up. It's extremely slow. It doesn't do anything useful yet, but it was like a proving point, like, yes, we can actually do something like that. Cool. So got out of my master's degree. I was like, okay, cool. I have a master's degree and a bachelor's. I have some experience. I can program in Python, C++. I've actually built robots before. I've worked with robots. I have an Ivy League degree. It should be easy to get a job. No, that was a big ego correction. Absolutely not. I applied to around 40 jobs that I thought were really interesting and a good fit, and only got 2 offers out of those 40 plus jobs. And the offer that I went with was an early stage company. And I can talk more about the why I think those rejections happened if people are interested in that. So I joined this company called Peanut Robotics, and Peanut Robotics makes still, I don't work there anymore, but they still are around and making really cool robots. And these are robots for cleaning. Don't think Roomba robots, but like full scale service robots that like have an arm on it and clean bathrooms, and mostly at hotels. Cool thing about that, I didn't have any manager. I was eventually a co-founder and worked not just in engineering, but in anything from sales and customer meetings and business development, partnerships, and investor meetings, and so on. So that was really cool. Also, just to figure out like, do I just want to do tech, or is there something else that I want to do as well? And is a startup thing something for me or not? So let's open up this video. This is a website. You can check this out yourself. Most of this stuff I programmed myself with the help of one of my colleagues. So this is a 7 degree of freedom off-the-shelf robot arm sitting on top of that mobile base, and has various tools that it grabs and can clean a bathroom. So we could do the tub. We could do clean in and around the toilet with a plunger with this like little turning thing, and then clean the sink as well. And so that was amazing because you can see 15x sped up. I didn't want to also give you the it takes about 15 minutes to clean a bathroom. We're not going to sit here and watch the whole thing. but what I learned a lot about, 3D mapping, localization, sensor fusion, motion planning for robot arms. It was really tough to make that robot arm go all the way from left to right. It's actually something that's very much under development in the robotics world. The whole concept of manipulation, and that is solved in like most industrial robots in a very like simple, shallow fashion. And so, when going into this, I was like, I know that service robots is hard, but this was actually trying to bring a product to market with robots. It's absurdly hard. It has to work every single time, and it didn't. it didn't for a long time. And you learn all of these side related things about manufacturing, and you learn about distributed computing and everything that you don't necessarily associate with robotics. But it kind of shows how like broad the field of robotics is, and that there's not just one kind of robotics engineer that you can become. Lessons learned, you don't want to write everything yourself. It's just too much. And so you actually become really good at trying other people's solutions and packages and things, and then fail fast and learn why they don't work and move on. Cool. So just take a retrospective break there. I would say I learned a ton of basics in college and in grad school, but you really learn so much more when you're actually starting a real job. And it kind of takes you need to have that like background in the basics to be able to do the cool robotics work for a company. But so if you can get the chance to do like short stints with a robotics company, by all means go do that. After that, I had now some experience, 2 years of experience. I built even more robots, more software experience, and I had a lot of connections once I moved to the Bay Area. And so landing a job went from like, this painful process to everyone reaches out and suddenly you're the most interesting person in the world, and for recruiters at least. And so I was actually, one of the companies that we use the software at Peanut Robotics, had this really interesting product, and they were like, hey, do you want to come work for us? And here's an interesting offer. And that's just kind of how that worked. And so the company that I work for now, been at for 2 years, is called Freedom Robotics. And we do, this kind of very, it's a very bland way to say it, but management and monitoring for fleets of robots. So think the sidewalk delivery robots that are driving around. You have 100 of those. You don't know where all of them are, and you want to operate them remotely. Freedom Robotics offers you a solution to do so. If you have tons of industrial robots or hundreds of industrial robots, be it mobile robots that move around, do logistics, move around goods, or industrial manipulators, robot arms, and you want to see where they are, what they're doing, how well they're performing. This is kind of the thing that sucks up the data and allows you to see it historically and real time. And the cool thing about working for a company like this is that I get to meet with a lot of robotics companies and users, as opposed to just working on a single robot and just being an expert in this one robot. I get to see how other people build their robots and what their view is on things, and not just technological. What are you doing with your robot, and like what programming language are you using, what packages and what middleware and whatnot, but also what is your kind of business plan, and how are you making money, and that kind of stuff. And so you really get to, when you work for a company that basically delivers software to other robotics companies, or some kind of product, you get to see much more than you would see if you work for a company that actually produces a product yourself. So that's really interesting, and something that you might want to consider when you're applying for jobs and considering offers yourself. I've been in the US for 7 years, and I still don't have a green card. That's just an FYI, but that's something that you have to think about if you're an immigrant. I don't know if there's any immigrants in the audience. I hope not. So a brief day-to-day on what it's like to work in a tech startup, because that's what I've been doing for the last 4 or 5 years. It's impossible to say, this is what my day looks like. It changes all the time from week to week, changes from day to day. Cool things like working for a young tech startup in the Bay is that you get things like unlimited time off. So if I want to not work for the next 3 weeks and still get paid, I can. And that sounds like an awesome perk, and it is. And I try to make use of it. But that's kind of the key word there. Trying. You want to make an impact. You want to work hard and have an interesting career and build robots and do all these things. And so you actually have little interest or time or will to take time off and go do other stuff. On the other hand, my company loves it when you build robots as side projects. There's various reasons for that, and it's not just robotics engineers; it's everyone on the team. Because you just become a better robotics person, you can interact with customers better, and you can do things like writing blogs about the robots that you build, which is a sales engine. People are attracted because you sound like you know something about robotics, and so that's all really cool. So at this job, a lot of the time I spend talking to our customers to learn about how they use our product, how they would want to use it, what day-to-day problems that they're spending their time on, and because that kind of gives you the opportunity to build new features yourself that you could build on your platform, which you could then sell to them for a lot of money, which is great. And so I spend some time writing blogs, not just for the company, but also for myself. And I'll go into why I think you should spend some time doing so, or some other way to build your personal brand. Last but not least, working for a startup can be very uncertain. You don't know if a year from now that company is still going to exist. So that's something to keep in mind. Startups sound amazing, and you learn a lot, and you make connections, and there's a potential financial upside from working for a startup, but a lot of them fail too. And so it could be that you worked so hard for years on something, and it could just say, like, it could just stop existing because of tons of reasons. So that's just something to keep in mind. So one of the projects that I do, or that I started 2 years ago, was the NASA JPL Mars Rover. And so this was a replica, or not a replica, it's kind of like a downsized version of the Curiosity Mars Rover that you can build yourself with off-the-shelf parts. So it's kind of like, I guess, the same size of your FTC robot, maybe a little smaller. But you can completely build it off the shelf with probably parts that you guys are familiar with. And this is not the most impressive robot per se, but the idea of this is also, the community outreach, education. And so we have a lot of young folks building this, and people who never played with robots before. And so what I do as a maintainer, this is completely free work as a side project, is make sure that these things stay up to date, write interesting code for it so it can do things like these. This video, we had to replace the motors with bigger, better ones, and so now the thing drove faster. And so you also do a little bit of community management, where you get to talk to a lot of people who use this for various reasons. Some people want to put an arm on it and do kind of deep learning grasping and some crazy off-roading with this thing, and some people just want to build it to drive around with an Xbox controller, and some people use it to move around their groceries, or like myself, because it's a ton of fun. Or skate behind it. If you look me up on YouTube, you might find me skating behind this Rover for fun. So I'm slamming through this. That's not the right button. Some unsolicited advice from a robotics engineer. For me, what I found remarkable is that once you graduate, you kind of spend most of your young adult life or teenage life focusing on grades and extracurriculars and whatnot. And grades in particular are so important, especially here in the US. But once you graduate, no one cares. Like no one, I don't even have my GPA on my CV, even though it's like a 3.9 something, because no one asks, and I don't want people to care about a grade, because I personally believe, and a lot of people I think agree with this, that getting good grades once you've graduated, it's more important to have use your time to make connections, worked on side projects, made friends, be generally happy over having a perfect GPA or whatnot. That's not true for everything. If you want to go in academia, it helps, and you want to do a PhD, it probably helps to have good grades. But if you want to kind of go down the same career route that I chose to go down, which is being generalist roboticists and working on real robots and that kind of stuff, grades really don't matter. So that's something to keep in mind. One thing that I wish I had known before is that it really helps at any stage in life, whether you're 18 or you're 45, to and I obviously can't speak for the 45-year-old people because I'm not that old yet, is to find yourself a mentor. And this can just be anyone that you think is like interesting, or you can look up to, or has some can give you good advice. And a great way to reach out to such people, you might not get an answer from people like Elon Musk if you think that they're really cool. But if you have like some connection, or like, this person's from the same area, or you can get an intro through your dad's friend or something like that, and you just send them a quick note and say, hey, like, I know you're super busy, but is it okay if I call you once a month? And you just kind of get the chance to yell at me and tell me what I'm doing wrong for 10 minutes. And that's essentially what mentoring is. The very like basic minimum that you could get. And then they will go and tell you, listen to your story and tell you all these kind of advice points. And what I think is important with that, people love giving you advice and love giving you feedback, just like I'm doing right now. And just listen to it carefully and try to understand where they're coming from, and then proceed to ignore most of it, because you know yourself better than they do. So a lot of advice is just typically not at the right stage of what you're looking for, or like you kind of have to experience it yourself before the advice makes sense. But it nevertheless, like having a mentor, someone who looks out for you, someone who can introduce you to other people, can give you like perspective on things, is really helpful. So I have a couple of mentors, one guy, for example, who started multiple robotics companies, and I just kind of ask him, what should I do with XYZ, or, if I want to be here in 10 years from now, what is this a good thing to do, and should I change roles, or and then they'll give you their perspective on things. So as I mentioned before, I do a lot of blog writing. If you look me up, you'll see some blogs written about the Mars Rover, where I write about technical things and I write about lesser technical things. And what I'll say is that, like, it's people typically underestimate how valuable their writing is. There's always an audience for what you have to say, and you don't need 10 years experience or be at the very top of your league to be able to write something that's useful. And writing something that's, some kind of blog about some side project that you're doing, about the FTC competition, about anything, is good, because you start building a brand around yourself as someone who like understands uh, the technical details, or knows a thing or two about robots. And that's really awesome when it comes to things like hiring, or you know landing a PhD, or landing some kind of job. And what I see a lot, even with people who are far more experienced and experts in robotics around me, is that they have some kind of writer's block that's like, I can't, because there's some other people who know even more about me, about this than I do. And they're going to have critique, or this is obvious to them. And that's just such a fallacy. Like, you don't have anything to lose by writing. And what you'll actually find is that a bunch of people reach out and say like, hey, that was really, really cool. I'm glad you wrote about that. And I learned something new. And if they don't, you spent some very little time on doing something like that. So, build that brand around yourself. I've gotten some really cool things out of it. Some of the blogs that I write, like, people keep referencing. We bring it up in sales meetings. I've had professors reach out to me because they found that some kind of technical concept that I explained, they couldn't figure out a way how to explain it in an easy way without sounding like overly technical. And so I strongly recommend doing something like that. Again, if you are interested in doing something like that, reach out and be happy to help you with that. Something that my advisor told me at Penn was to focus on the basics as much as possible. And with the basics, I mean like your math classes and your geometry and linear algebra. And when I say geometry, it can also be differential geometry, so beyond just triangles and circles. But find the things that you're interested in. And the reason for those basics, studying the basics first and doing them well, is because that kind of stuff never will get old. Calculus is not going to change in the next 100 years. I mean, I hope. And so getting really good at that, linear algebra in particular for robotics, optimization, all of those things that kind of seem boring, will actually go a very long way in helping you with the more fancy, shiny stuff. Like, the recent, this is like 5-6 years, hype in or wave in deep learning. It's all very shiny and cool. But that's probably going to be replaced with some kind of new framework or something else in 5 years. And so if you just became a specialist in that one particular deep learning algorithm, reinforcement learning, or GANs or convolutional nets or something like that, that's awesome, and it's you'll learn something. But after a couple of years, that will become outdated information. And because you lack the very solid understanding, the underpinnings of what makes these things work, you're not going to be able to ride the next wave of the next algorithm, or be able to write that yourself, or be part of that yourself. And so, yeah, it's just really crucial that you stick to those basics as early as possible, because the deep learning part is really not that complicated if you really know your basics well. So, and then the last part of advice that I have is that I've seen a lot of colleagues and friends move very quickly from a tech role to, like an engineer, software engineer, mechanical engineer, to something like product management or engineering management. And that's okay. And that's something that, I would never say that you shouldn't do. But if you're kind of debating whether you want to stay in hardcore engineering for a little longer, or if you want to go into more like a managerial role, stay in engineering for a little longer, because what that'll actually allow you to do is grow into a bigger role, like a more influential role, faster later in life, if that's what you're interested in. because you have a deeper understanding of technology and you have like more of a rep as a technologist. And also because if you do go to that non-tech position after you've been out of touch with programming and technology for a couple of years, it's typically hard to go back to a more technical role, because you just forget and you're not up to date with the latest stuff. Yeah. Okay. So this is that kind of concludes the end of my talk. I don't know how we are on time. I don't know if I was supposed to do half an hour.
That's fine. Yeah, that was awesome. We do have a bit of questions. I'm kind of echoing, but I think the majority of the questions are about your role in the company, and like, I guess, can you take us through more of what you do at your job, like the larger goal of the company as well?
Yeah, absolutely. So I guess I should have. I didn't really quite show this to understand what really our product is. Let me just show it. Here's hopefully if it loads. Oh, this is one of our robots that's sitting in the office, and you can see all of the data live coming off of it. So this is kind of part of the product that we offer. Someone happened to turn off the lights in the office, so this robot, it's a big industrial, like a big fetch robot with an arm, and drives around. So you can't see anything, but let's see if I can, if I turn it around, maybe that it'll see the light or something like that. And so this is kind of the aspect of our robot where we actually of our product where we interface with robots directly, and that is less on the industrial side. So you can see something blinking. That's probably the robot themselves. I can send it a command to go and do something, and I can see like what the robot is up to. I think it should have turned around, and then I can click on the screen, and that should hopefully like make it look around. But yeah, it's very dark in the office, so you can see somewhat of light. So this is what people use to actually drive their delivery robots on the side of the street. What this also allows you to do is look at the data coming from the device directly. So if some robot has an issue, you can see it like, 2 days ago it broke down. You want to see what happened right before that. This allows you to do that, which is really cool. And then there's a ton of more features that are hidden into this, but you get kind of the gist of what we try to do. And so my role at this company, I'm a robotics engineer, and we don't actually, like, our core product isn't robots, it's software. And so a big part of what I do is actually sitting with customers and help them be efficient with their robots and make sure that their robots are working so that they use our product more. And I help develop this platform where I say, like, hey, something that we really want to look at is the LiDAR feed. So that I don't know if everyone's familiar with LiDAR, the laser scans from around the robot. And we want to visualize it in this particular way so that it's useful. And so you bring that kind of robotics perspective to a software platform that is designed to be used by roboticists, but also by people who don't have that robotics background, but are end users of robotics, which we see a lot in the industrial space. And we do a lot of, if there's some kind of robot brand that comes out, there's hundreds of robots brands out there. They'll have some different interface that you can pull data from the robot. And so part of what I do as well is write that code that pulls the data from the robot and sends it up into this platform so they can visualize it. And that is more close to pure software engineering, which is also cool because in previous experiences I learned all about like robots themselves and what's inside of a robot, and this is kind of like the ecosystem around the robot. Yeah, did that make sense to everyone?
Yeah, that's awesome. Thank you. And then I guess our next question is kind of related to that. Just like, what are the applications of Freedom Robotics tech, and where can you see that heading in the future?
The tech stack, or what did you say?
The question just said like the tech in general, like what you guys are doing at the company.
So how our customers use it, or
Yeah.
yeah. So as I mentioned, there's the delivery companies out there, which is a good example. Very simple. They just want to log in. They have operators. They log into the software, and they drive the robot remotely. And really, the entire idea of Freedom Robotics, the reason it was started, is because as a robotics engineer, as I mentioned before, you spend a lot of time doing non-robotic stuff. I had wrote databases, like or code for databases, and I set up database clusters so that the data from the robot was getting stored, and I could look at it later. And it's really something that you don't want to be doing as a roboticist. One, because you're not good at it. Like you're typically trained as a mechanical engineer or an electrical engineer, software engineer, but not as like a I guess like a specific software engineer that deals with APIs and application programming interfaces all day. And so the idea of Freedom Robotics is really to take that, do that, all of that stuff that roboticists used to do it once and for all, so that they can focus on the things that really set their robot apart. And in our case, at Peanut, that was cleaning bathrooms. And so, I spent like up to 90% of my time on doing non-robotic stuff. And so that's kind of the hope that we do here. We solve it once and for all for everyone. The other thing that we do, actually, a huge part of our revenue and our customers are industrial roboticists. So that's actually, instead of selling our software to robotics engineers, we're really selling it to these corporations. A lot of industrial robotics is like car manufacturing, warehouse logistics. So where they have, mobile robots driving around from one place to another, moving motors or axles or parts of any part of a car. And they just have these 3 different brands of robots moving around, and they have traffic lights set up within their factory, and they have simple buttons that someone presses to make a robot come over and pick up a part. And all of that stuff typically gets done by what's called systems integrators. And so these are fairly large groups, and there's hundreds of them across the US and beyond, that just specialize in making these different robot brands and peripherals, so the buttons and the traffic lights interact. So that's always done kind of on an on-off basis. And so, that company that's running the factory or the warehouse says, okay, I want to move my production line a little bit around, or I want to introduce this new brand of robot. And each time that they make a small change, they have to call in that systems integrator to say, hey, can you guys come and reprogram this so that it works with our new system? And that's obviously not a great thing to do. You end up spending a lot of time on it, and everything gets and money. And so one of the things that we also do is kind of provide that abstraction layer. So where we say, all robots have these fundamental truths about them, and all buttons kind of look like this, and all traffic lights kind of look like this. And that which means that our end user can, the people running the factory can actually do the programming themselves. And so they basically pay for the plugin that makes that abstraction. And so we go and install our code on their servers, and it picks up on all the robots and all the devices that are there. And then they can do the programming themselves. So they want to say, if this button gets pressed, then this robot should move there. And if this robot is at this intersection and the other one is around the corner, pause this one so they don't crash. And so that's kind of the stuff that we're really getting into. And it is, industrial robotics typically lags behind on the rest of robotics by probably a decade. And so we're kind of on a mission to bring that to modern times. So bring modern abstraction and modern software to factories.
Awesome. All right. Next question is, How long does it take to go from an initial idea for a robot to finishing building and programming it?
Not very long. There's one. It really depends on the robot too. But one of the side projects that I'm working on right now is I call it a stair lift. It's basically one of those old people lifts that they go sit on to go from one floor to another, but much smaller, easier to install, cheaper, off-the-shelf parts for robots. And so a robot like your Roomba can drive on this, get like moved up the stairs to the next floor and continue cleaning there. And that's just kind of a fun side project that I've been doing. And I kind of had the idea in the back of my mind, and it kind of started building, becoming concrete. And then one day I just went into our own office here in San Francisco and ordered some parts online, drew a design up on my on a piece of paper, and just saw like, is this a method that's going to work? So I like had a couple of ropes set up, a little motor attached to it that I just manually made turn around, and then that kind of sent the platform up and down. And it was like the most basic, almost cardboard setup that you can think of. And it just made the thing real in my head. And then once that was going, I went through another 11 iterations before I had something that actually worked. So I spend very little time actually thinking. I just spend a lot of time trying. And then once I have that, then I go back to the drawing board and I make it in CAD, and I write actual code for it as opposed to doing manually. But you want to learn and iterate as fast as possible before you're like, okay, I'm going to do the industrial design on this, and I'm going to like bring in a product designer, or I'm going to make up a whole team around this idea. So just fail as fast and early as you can. But yeah, I mean that's with the stair lift. When it comes to a real robot, kind of the service robots, I really do everything in pieces. Where typically a mobile robot like the ones that I'm used to work with, there's that concept of the mobile base, which its main function is just placing the arm into a position that it can reach. And so that's navigation, that's 3D mapping and localization, and that kind of stuff, and path planning. And so I kind of consider that entire segment different, or that entire part of the robot and its software as a different part than the manipulation side, and then the 3D and perception side, the language processing side. And so you kind of iterate, of course, with those things, but as you have more expensive components, like a 7 degree of freedom robot arm, you really have to have thought out your work and your plan before you start building that.
Got it. All right. We have a pretty large influx of questions, so I'm gonna start combining some of them. So two people asked kind of the same thing. What robotics or automation project are you most proud of? Another person asked for your favorite project you worked on. So let's go ahead and answer both of those.
So what was the first one? What's my favorite robotics project, or my favorite robot?
A robotics or automation project, yeah.
Yeah. On the software side, if you look up my name as it's spelled there and you type in Cuspidal robots, there's a talk that I give about Cuspidal robots, which is and a blog that I wrote about it, which is a type of robot that very few people have heard of. And it's a very interesting concept or type of robot arm that very few people know of. And that's something that like a couple of research papers existed about. It's not something that I discovered or invented. But it was just such a niche, unknown concept. And I was like, hey, I think this is important. I'm gonna write about it and bring it up and talk about it. And actually gathered a lot of interests. And as I was trying to explain what this was, I actually gained a really deep understanding of the concept itself, and made some things that no one had seen before. On the robotic side, I think my proudest robot is the robot that we built at Peanut. That was a pretty amazing platform, and I've seen the stuff that you guys do at FTC, which is also really cool. This is kind of like my version of that. There was just a lot of software that went into that thing, and a lot of mechanical engineering, electrical engineering. So,
Gotcha. Okay.
what was the other question?
It was pretty much the same thing. Like, what's your favorite project? So, yeah. Next few questions. We had one person ask why UPenn was a good university for robotics, and I getting back to that. And then another person asked about your experience at Penn and if you did incorporate, business today.
Yeah. First of all, there's a ton of really good research or universities for learning robotics. A couple of them undergrad as well. I can think of WPI, Worcester Polytechnic Institute. I think there's a couple of other universities and more coming out every year with their own robotics program. Penn was excellent. They didn't have an undergrad robotics program, but they have the master's. And Penn is known for the GRASP lab, which is it's not a lab, it's a collection of labs. With various professors doing completely different kinds of research. There's like Mod Lab within GRASP Lab, which makes like modular robots. There's Kumar Lab, which makes flying robots and makes them like fly together and like in groups and do backflips and whatnot. There's COD Lab, which is the company that spawned the lab that spawned the company Ghost Robotics, which make the quadrupeds, the Boston Dynamics style one. So you have like the whole, suite of different kinds of robots. And then there's a lot of more software oriented robotics labs in there, which do more like reinforcement learning and computer vision kind of stuff. And so that was really cool for me because I consider myself a generalist robotics engineer as opposed to a specialist. And there's a lot of specialists out there. And we of course need the specialists, the people who are really good at drones, or the people who are really good at deep learning, or the people who are really good at computer vision. And so what was cool about Penn was that I could kind of see a little bit of everything and figure out what I really wanted to do, because I didn't, I had no experience in robotics before starting that program. Other universities that are really good are universities like Carnegie Mellon University, which tends to be more on the computer science side of robotics. So they do, they're also all-round research university, but compared to Penn, they would do more software as opposed to Penn does more mechanical stuff. Penn is also known for the flying robots. Stanford, but it's just so varied. What you really want to look for, if you already know what kind of robotics that you're interested in, is not the school or the brand name that's associated with it, but the person that you might work with. So if there's an interesting professor, or even postdoc at some university doing robotics that makes you go like, wow, that's amazing, and it's some lesser known university, that actually might be a better option than going to a brand name school. And the reason for that is that you actually, with like a superstar professor at some kind of brand name school, is that they'll have very little time for you and to educate you, as opposed to a smaller school where they have a good professor who's interested in the same thing that you're interested in. You might actually go work with them and for them, and get a lot of experience that way.
Awesome. All right. We'll do 2 to 3 more questions. I think we're already over time, but there's a large influx. So I guess this one's pretty long, so let me know if you need me to repeat it. How difficult and what obstacles did you face when you guys were like pioneering a startup compared to seeking a job at FANG? I believe that stands for Facebook, Amazon, Apple, Netflix, and Google. And why did you do it personally? And what advice would you give to a high schooler who's also interested in becoming part of a startup?
Yeah, that was indeed a long question. Can you post that in the chat, or is there a place that I can find these?
Yeah, for sure. Let me help you with that.
Yeah, I want to make sure that I answer the whole thing.
Gotcha.
Challenges with startups. So many. I did it myself from scratch, and especially in the beginning, if you've never done a startup before, you have really no idea what you're doing, and no idea what you should be spending time on. One very common pitfall for engineers is that they spend too much time on the engineering and too little time on doing the business development and meeting with customers. And essentially, when you start a company, you really want to understand what is it that I'm solving, because people will care about the robotics aspect for the full 5 minutes, and then they won't care. They will care, does it actually solve my solution? And so if you're trying to look for a problem that matches your robotic solution, you're most likely going to fail. And on the other hand, if you have a good understanding of what the problem is, and after trying every single option, you find out that robotics is the right thing, that's when you're in a really strong position. And if you truly believe that, that's when you just keep fighting for it and keep going. But yeah, what I see a lot, and a mistake that I made myself, is trying to perfect a robot and not really understanding what you're competing with, what the solutions that they have, that your customers have today, and if it's possible for you, even with the robotics technology, to do better than what they have today, because it's a business model, or it's a kind of business that's very new. It's not very understood. And there's a lot of like businesses coming out right now that have to deal with things like regulation. For example, a lot of the sidewalk delivery robots failed because they just got banned. Look at Toronto a month ago, banned all robots from venturing outside unless they have some kind of license. And so those are kind of like the unexpected things that you have to deal with, beyond just trying to build a product that doesn't exist yet. How difficult and what obstacles when pioneering? So I did that. Becoming your own boss. Becoming your own boss is, well, I guess first of all, if you have investors, you're not your own boss really anymore. You just get to decide. Really what you have to do at the end of the day is, you typically have like a quarterly board meeting or even monthly board meeting, which means that all the investors come and grill you on what you're not doing right or what you are doing right, and how they can help. So you're never just going to be like, I do whatever I want. If you do whatever you want, you're probably not going to do the right thing. But running a startup and having people under you and work with you and for you is more of a responsibility, and you care about them. You want them to be successful. You don't want to have them waste all their time on something that's not going to succeed. So it can be stressful, but of course, it can also be so rewarding, because you're really doing what you're interested in and what you're passionate about. Comparing to a job at Fang, I've never worked for a very large company. Sorry for the background noise. So I don't really know what that would be like. But that's also just a choice that I made for myself. Like I love working in a small company environment with a small team. And I will say, if I were to go work for a FANG company, or like an Amazon Robotics or something like that, you will make much more than you do in a startup. But that's kind of a decision that you make yourself. You're making good money already as a skilled software engineer or robotics engineer, and is it I guess there's different pros and cons. If you work for a FANG company, there's also not the ability or the chance that your startup wins the lottery and gets bought or does an IPO and your shares become worth a lot. So can't really comment on working at a really large company, but it's if you have the option, do both and see what you like.
Sure. I think we are a bit over time, so I'm gonna try to wrap this up. We do have a few more questions, but I'd encourage you guys to email them. Is it possible for us to send the guests your email? And if you have any
I'll type it in the chat.
Okay.
You're welcome to reach out to me, Achille at freedomrobotics.ai. You can also go and find me at Achille.fyi. And this is also something I didn't mention in my talk, but after a couple of years, in the beginning, it's easy to have a CV. After that, you just kind of forget what you did in the past. And so if you can make this website that I just posted is just a Google Sites page that links to a domain that I bought. And so it just lists all of my portfolio. And it's really easy for recruiters to see, this guy has the right experience or not. It's much more interesting than a CV. I interview people regularly, and I've done in previous jobs as well. And it is true when people say, we don't look at your CV, or we look at it for like the full 10 seconds because it's so boring to look at. Oh my God. So give me some pictures, give me something interesting, the projects that you've done. That tells so much more than the positions that you've had. Yeah, you're very welcome to reach out to me at that email, or my personal email is also on that website. Either works.
Awesome.
I'm happy to answer questions.
Okay, cool. Thank you guys so much for coming, and thank you, Mr. Achille, for agreeing to give this awesome presentation for us. So there's emails in the chat, and I think that should be about it. Thanks for staying 8 minutes over time as well. Yeah, you guys are free to go. Thank you so much.
Yeah, thank you for having me, and good luck, everyone. I'm excited that you at such a young age already know that you're interested in robotics and exploring and learning, and being able to do such activities. I probably sound like an old timer here, but I never had that chance. I also didn't know that I wanted to do it, and so it's really awesome that you guys get to do that. So good luck.